Hello, VR students. I wanted to follow up on today's lecture, tutorial, whatever you want to call it, with some bonus information. So first, uh, uh, Ariana, I promised you that I would put this information on the website, Discord, Blackboard, something. So here we are. Uh, but I was thinking about it, and I don't like to give away too much because I want you guys to think on your feet and develop as much independent stuff as you can. Because really, that's how you learn stuff. But I do want to add a few little things to our example from class today. So here is our movement code for the DIY flying through the virtual world. There are other ways to do this. Matter of fact, there's probably some prefabs built in to the OVR player that'll let you do this. But understanding the fundamentals of how to build this and make it happen is applicable to any headset. Even if the name of the thing you need to call isn't OVR input or whatever, still the basic fundamental aspects of making this work, at least for the mathematics of it, will apply no matter what headset you're using, or even if you're not using a headset at all. If you're using game controllers or doing something on a 2D screen, these same fundamentals will always apply. But the cool thing is the tools that you're adding to your toolbox learning how to do this will help you with whichever navigation method that you're coming up with. Again, I'm probably repeating myself from class, but still just making that point. Okay, so let's see. Let's actually expand this out just a wee bit. Guess this is as small as Unity is going to get for us. Um, okay, so there we go. So we can see this whole thing here. Okay. So where we left off is we made a game object that we called our movement controller. Honestly, you could just attach these scripts to almost any game object in here and do the same thing, but to sort of keep them conceptually organized, I usually like to make a game object that doesn't do anything except house scripts to do other stuff. In this case, we made a movement script. So this is just what we're calling our movement controller. And we attached to it this file here, and it's movementexample.cs, so our C# script. And we pulled in two public game objects, HMD, which is our OVR camera rig, and the eye, which we're using for this is our center eye anchor. Okay. And so again, over here, what we're doing is we're just listening for any activity on the A button on our controller. And if we got some activity, then we're just going to translate the camera rig, in the direction that the person is looking. And again, we added this debug statement here just so we could illustrate, that that's what we were doing. And we were calculating a direction vector that was the local rotation of the eye anchor multiplied by what we've defined as our forward direction. Now we did this, we took a shortcut here. Notice we did 0, 0, 0.01. And so this could very easily just be a unit vector. And that unit vector is your forward direction in your world coordinates. So technically, you could just make this, a unit vector facing down the z-axis. So make it 0, 0, 1. Now the problem here is that every time you push that button, you're going to move one unity unit, which we typically just consider that a meter. So if you do the math, pretending those are meters, it comes out to be, guess what, a meter in the end. So every time you push that button, it'll move you a meter in the direction that you're looking. But that's not always the scale of movement that you want. You sometimes want it to be smaller, sometimes you want it to be larger. Well, you can apply a scale factor directly to that vector. So for instance, let's make something called movement scale. And let's make a float and movement scale. and set it equal to, for every button press, we want to move, say, 1 centimeter. And remember, this is C#, so if you don't put an F after it, it's not going to think it's a float and it's going to complain about types. So 0.01 F. And this should give us the same movement effect that we were getting in our in-class example where we had 0.01 as the direction vector instead of 001 or 0x 0y 1z. So defining that the direction that we're moving along the z-axis. Okay, so let's save that and click over here. We got the weighty hourglass because it's recompiling our scripts, and let's launch it and show the difference. Or rather, show the lack of difference, because this actually should look exactly the same as what we were seeing in class. See, yay, moving in the direction we're looking. But sometimes you want the ability to modify these things. And sometimes, especially if you're running a PC VR headset or running, your Quest over Link, now this is more of a general Unity thing, not specifically a Quest thing, but you can make other kinds of public variables. For instance, we can make a public float, and we'll call it our movement scale. Now notice this isn't initialized to anything, okay? What we can do though is in the start function we can initialize our movement scale to something like 0.01 F. We won't need this anymore because now it is a global public variable. What's the advantage of doing that? My basic programming class told me, try to avoid global variables whenever possible because it's bad programming practice. Well, everything is dependent on the context within which you use it. There are certain circumstances where using a hammer is completely appropriate. There are other times when using a hammer is not appropriate. Everything is a tool. It has its time, it has its place, it has its utility. And a good programmer learns to know when to break the right rules and when to adhere to the right rules. So keep that in mind. So we just made this public variable called movement scale. Let's go back over here to our Unity project, let it recompile, and look, there's something here that says movement scale. Now it's initialized to 0 right now because our environment was still running. Let's start it up again, and look, there it goes. Neat, right? Now why is this neat? Well, one, it's going to make your life easier in the long run because even if you're not manipulating it at runtime, gives you a nice place to edit parameters like your movement scale without having to go back and edit your scripts. So we could, set this to 2.7. Now you're going to move 2.7 meters for every press of the button, or for every frame that it's held down. So we're going to move really fast now. Whoop! So fast that we zoomed right through our geometry. Hey, look at it. There it is. Now, quick press. Woo, too fast. And that's really neat. So you can edit this in the inspector when you make it a public variable. And as long as you save that when you're not in preview mode, that setting will be retained without you having to go back and modify your script. Okay. The other neat thing is if you're using this for like PC VR, so a headset that's tethered to your computer, or your Quest when it's in link mode, you can also use it to dynamically adjust. Look at that. By clicking on the edge, it gives you this little pointer like that. You can click and hold and then drag it side to side, and it'll let you adjust the value of that parameter just by scrolling side to side. And that can be pretty darn useful as well. Okay, let's see. Actually, I slightly misspoke. If you wanted to initialize to something, you're going to have to do this. But if you want to have it something that you can modify in your inspector and save it, you can omit this step. And if it's not set in your inspector, it'll gripe at you in the console when you try to run it. But yeah, let's do that and click play, and there you go. Now it should retain it when we exit. Yep, it keeps it at 0.39. Now, one of the things to keep in mind is that if you edit your inspector values while you're in preview mode being clicking this play button, if you edit your inspector values while the play is going, they're temporary. Once you get out of preview mode, they're going to disappear. So be sure that if you make something in preview mode and you want to keep it, write down those numbers and put them back in once you get out of preview mode. Preview mode is temporary. It is ephemeral. It is for you to preview your settings. They're not permanent. And that bites everybody every now and then, myself included. I've been working with Unity for years, and I still forget that sometimes. So keep that in mind. Okay, so I'm going to post this movement script to Discord, and this is otherwise the same example that we walked through in our previous video, so you've probably got a version of this on your machine already. If you have questions, let me know. And otherwise, I will see you guys in class. Have a great weekend.